Lesson 3.4, I break this into part 1 and part 2. Today is long division. Tomorrow, we're going to learn something new called synthetic division. Synthetic division will be brand new to you, but you'll like it. It is 100% easier than long division, and it takes the place of long division in certain circumstances. Okay? For right now, in order to appreciate synthetic division tomorrow, we have to review long division. Now, I learned years ago that teaching long division of polynomials goes a lot better if we review our elementary long division skills. What did you guys all freak out about when you saw this? What? Without a calculator? Wait, you want me to do that? Yeah, I do. Okay. So, 96,456 divided by 25. Let's start basic. What goes in the box? 96,456. And that means 25 goes outside the box, yes?
Yes.
Okay, guys. What do you remember? We're dividing by 25. So what are we going to put 25 into?
96.
Okay, so 25 is a 2-digit number. So we're dividing it into a 2-digit number. How many 25s in 96? 3, yes? And as I said when I was taking attendance, I gave you 25 because I gave you an easy number there, didn't I?
Yes.
25. You're counting quarters, okay? So 3. Where do I put that 3? Since we're going into 2-digit, it goes above the 6 in 96. Then what do we do after we put that 3 up there?
3 times 5.
Okay, we're going to officially multiply. So we're going to take 3 times 25, and we're going to get,
75.
and that 75 goes under the 96. And we're going to what? Subtract. 96 minus 75? 21. Now what? Okay, now we're going to bring down the 4. And now I'm going 25 into 214.
8.
I'm going to go 8. Okay. And, okay. 4 quarters, here's this. 4 quarters is $1, so 100, right? So then we're at 8 quarters. That 8 is going to go above the 4. And then we're going to take 8 times 25 and get 200. And I'm going to subtract. 214 minus 200? 14. And remember, this number when you subtract should always be smaller than your divisor, yes? Should be smaller than 25. Okay, now what? Drop down the 5. 25's in 145.
5.
Doesn't quite go 6, does it? So we're going to put the 5 up here. 5 goes above 5. 5 times 25? 125. And then we're going to subtract. 145 minus 125 is 20. And then
8.
bring down the 6. How many 25s in 206? That is 8. 8 times 25 is 200. And then I'm going to subtract. Now, we're not going into decimals. I had some of my morning class. I didn't give them directions. I just said divide it. They kept going and got decimal. Could we add a decimal, add zeros, keep going? You could, but I'm not going to be able to do that when we divide polynomials down here. So what is 6? This is called your remainder. Back in the day, when you first learned long division, you didn't start straight with decimals, did you? You just got to put R6 at the end. Okay? Now, we're not going to use R6, but another piece of vocabulary. What is 3,858 called?
Quotient.
Quotient. The answer to a division problem. is a quotient. So when they ask you for a quotient today in homework, just realizing they're asking you for the answer. Okay, this is your elementary review.
Does that mean something, quotient? Does it mean like answer? Like
The answer to a division problem.
oh, but like is it like a different language or something? Or is it just like
Not to my knowledge.
Is it like French? Like la question.
Okay.
right?
Okay, we got our elementary review in, yes? Okay, let's transfer to algebra. Okay, so there's going to be some of these pieces that you needed to know, which is why we went through long division. But there's going to be some tweaks that are a little bit different. Okay, so divide the polynomials using long division. What are the quotient and remainder? So let's start basic. Let's set it up. What goes in the box?
4x
4x squared plus 23x
minus 16
minus 16. So what goes outside the box?
x plus 5.
X plus 5. And we'll talk about this more as we go. This is our beginning problem, so it doesn't have an issue here. But you always want to make sure that all of your pieces, we need these to be in standard form. In other words, here, if the highest term is x squared, then we have x squared, x to the first, x to 0. Okay? Same thing in your divisor here. Okay. Now, we are dividing by 2 terms here. And so it is going to affect where we put our answer. But to figure out our first piece, just take the x, your first term, and your first term in your dividend there. So you're asking yourself, like on my last problem, we said what? How many times does 25 go into 96? Yes? That's kind of how we asked it. Basically, when we said how many times does 25 go into 96, it was 25 times what number is 96, or closest to. Well, now I'm going to say, when I say how many times does x go into 4x squared, think of it in terms of x times what is 4x squared. So x times what is 4x squared. So I'm going to have a little bit of side work over here. You may or may not need this side work for yourself, but this is kind of little helpful hints there. So when I say how many times does x go into 4x squared, x times what is 4x squared. And if you're looking at that saying, I don't know, Mrs. Sargent, I don't know x times what is 4x squared. Well, what's the opposite of a multiplication problem? Divide. So turn it into 4x squared divided by x. What?
I was going to ask if we had to do long division.
Had to do what?
Long division.
This is long division. Answer this question right here.
4 squared. Oh, 4x. I did long division.
Okay. I'm in the process of long division. Unless you have done long division before and know how to do it, you need to stick with me. Okay? X times what is 4x squared? If you don't like that statement, then 4x squared divided by x is what? Can we agree one way or the other 4x?
Yeah.
Okay. So 4x is the first part of our answer. Now, how many terms are we divided by? 2. So that determines where we're going to put this 4x. Okay, this 4x, because I'm dividing by 2 terms, I'm going to count over 2 terms, and 4x is actually going to go above the 23x. Now, you can look at it one of 2 ways. We're dividing by 2 terms, so it has to count over 2 terms, or it's not just coincidental, but 4x ended up over its like term. 4x is like terms with 23x. It will always, if set up properly, it will always end up on top of its like term. Now, what do we do with this 4x? What did I do with the 3 here? Once we put the 3 up here, we had to multiply, yes? Okay, same process. We're going to take 4x, and what are we going to multiply it by? X plus 5. So really what you're thinking, it's like a distributive property, right? You're doing 4x times x, which is 4x squared. 4x times 5, 20x. Okay, so you with me? 4x times x was 4x squared. 4x times 5 is 20x. And now what do I do? No? Subtract. Because once we got the 75 on the previous problem, what did we do with 96 and 75? We subtracted. Subtract your like terms. If done correctly, these should all be like terms. 4x squared minus 4x squared cancels. If done correctly, that's what you're setting yourself up to do, is cancel out. So those should be canceling to be 0. 23x minus 20x. 3x. Now, what do you think we do next? Now we're going to bring down the minus 16. Repeat the process. Okay, are you with me here? We're going to go back, and we're still using the x, but this time we're asking ourselves, x goes into 3x. So, you know, my elementary, my non-proper form is how many times does x go into 3x? Really, it's saying what? X times what is 3x? That's really what we should be asking ourselves. And if you don't like x times what is 3x, then you turn it into division. What is 3x divided by x? 3. And does that make sense here? X times 3 is 3x, yes? Okay, where do I put that 3? Above the 16 here. And that is a positive 3. So I'm going to say plus 3. What do I do with that 3? You're going to multiply it by our x plus 5 out here, right? So you're doing 3 times the x plus 5. What is 3 times x? 3x. What is 3 times 5? Plus 15. So 3 times x is 3x. 3 times 5 is plus 15. And what do I do next? Subtract. 3x minus 3x?
Cancels out.
Cancels as we want it to. Be careful. Negative 16 minus 15. Negative 31? Yes? And what about that negative 31? That's your remainder, yes? Okay, and this is why we're not adding a decimal and a 0 earlier. I'm letting you stop at remainders, because can we add a decimal and a 0 here? And we can't really, can we? Okay, and so a little bit of vocabulary here. We already said the remainder was negative 31. What's the quotient? 4x plus 3. So if in homework it's asked, what's the quotient, what's the remainder? You have that information here. Now, they may ask, what's the quotient, what's the remainder? They may just say, divide using long division. And if they say divide using long division, do you remember how to express this? And I'm not talking 4x plus 3 are negative 31. Let me backtrack for a moment. Do you remember how to express this answer? Not using an R and not using a decimal. This is 3,858 and 6 over 25. Do you remember that? Remainder over the divisor. How you went for a fraction answer. It's been a few moments, right? Okay. Well, that's similar to what we're going to do here. So I'm going to say 4x plus 3. Now, officially we say plus. What's our remainder? Negative 31 over our divisor of what? X plus 5. So plus negative 31 over x plus 5. Now, here's the deal. What did I just say here? Plus negative. What's going to be the better way to put that? 4x plus 3 minus 31 over x plus 5. So if they just say divide, that's the answer you're looking for there. If it's a positive remainder, it'll be plus this fraction. If it's a negative remainder, it's minus this fraction. Okay. We're going to do a few more examples, obviously. Did we kind of get it? Kind of follow? It's different, isn't it? Do you see why I did the elementary long division first? I needed you to remember the basics of you multiply, then you subtract, you carry down the next piece, you repeat, you multiply, you subtract. I needed us to remember that. Okay. Ready to move on? Next one's just more practice. I mean, there's a few topics, some, all of them are just kind of more practice. There's a few little things that pop in here and there. Okay. This next one is expressed as a fraction, but it still says what? Find the quotient using long division. With that in mind, okay, set yourself up. What goes in the box? 3x squared minus 29x plus 56. What goes outside the box? X minus 7. Now, I mentioned it last time. I'm going to mention it again because it becomes important on the next one. I believe it is. Always make sure all places are represented. So if your highest power is x squared, what comes after an x squared? X to the first, and then x to the 0. X to the first, and then x to 0. Always make sure all place values are represented. If not, we'll have to do something. Okay, you ready? What are you starting off asking yourself? How many times does x go into 3x squared? Don't worry about the 7. Don't worry about the 29x. They kind of just tag along and they work themselves out, okay? Just worry about the x and the 3x squared. Or in other words, x times what is 3x squared? 3x? Yes? And again, as I said, if you don't like it, can you turn it into division? Yeah, 3x squared divided by x is 3x. Okay, where do I put that 3x? It goes above the 29x. 1, that's its like term, yes? 2, I'm dividing by 2 terms, so I'm going over the second term. What do I do now after I put the 3x up there? Yeah, we're going to multiply here, right? 3x times x is 3x squared. 3x times minus 7, minus 21x. And I don't know if you needed it, but does it help if I show the distributive over here? Some of you are going to want that. Some of you aren't going to care. 3x times x was the 3x squared. 3x times minus 7 minus 21x. Okay. And now we're going to, what are you doing? Subtracting. 3x squared minus 3x squared cancels as I expect. What about this next one? Negative 29x minus negative 21x. It's negative 29 minus negative 21, yes? So negative 29 plus 21, negative 8x. Okay, and then repeat the process. Drop down the plus 56. And as you repeat the process, this time it's x, and we're asking ourselves into negative 8x. Are you there? X times what is negative 8x? Negative 8. Divide it if you prefer, right? What do I do with the negative 8? Put it above the 56 in your answer area. And that's above its like term, yes? Take negative 8 and multiply. Negative 8 times x is negative 8x. Negative 8 times negative 7 plus 56. Okay. With that in mind, we are subtracting. That's negative 8x minus negative 8x. Cancels. 56 minus 56. Cancels. What just happened? Yeah. We officially have a remainder of 0 and a quotient of 3x minus 8. If you're asked for the answer, what's the answer to this problem? 3x minus 8. Okay. I'm going to talk about this a little bit on the back side also. Because there's a remainder of 0, it divided evenly. It divided nicely. What that says is that x minus 7 is a factor of 3x squared minus 29x plus 56. And I'll put some details about that on our next example. But when you get no remainder, it tells us it's a factor because it divided evenly. Excuse me. Okay. Gain you a little more confidence? Okay. You thought you couldn't do long division. Okay, guys. On the back side, 2 more examples. There's tweaks in both of them. In the first one, find the quotient using long division. Same old, same old. There's a hint here. Don't forget to write the polynomials in descending order and fill in any missing terms. That's important here. So, as you set this up with me, stay with me. What goes in the box?
2x plus what now? No. 8x cubed plus 27.
Okay, 8x cubed plus 27. So, the first term there is 8x cubed. What should come after an x cubed term?
An x squared.
An x squared term. Do I have an x squared term?
No.
No. We want to have an x squared term, though, just for organization purposes. Okay, we need an x squared term just to keep everything lined up nicely and organized. So if there's not an x squared term, and I want one, we're going to put a placeholder 1 in. So we're going to put in a 0 x squared. Because does 0 x squared mean anything? No, but it's holding my place. It's going to keep all my like terms lined up. Okay? So what should come after an x squared term?
X.
An x. Do I have an x term? No, so guess what I'm going to do? I'm going to put a 0x. What should come after an x term? A number term. a constant. Do I have a constant?
Yes.
Yeah.
Yes, so I can now put in my
27.
plus 27. Okay? All divided by 2x plus 3. Now, same thing needs to be true here. But my first term is an x term. What should come after an x term? A number term, so it's all good. So this is just divided by 2x plus 3. Okay? You good? Okay. Same steps now. Start with 2x. How many times does 2x go into 8x cubed? Or, more mathematically asked, 2x times what is 8x cubed? And if you're still staring at that saying, huh? Then turn it into division. 8x cubed divided by 2x is what? 4x squared. Okay, now, where does 4x squared go?
Over the 0x squared.
Okay, above its like term, the 0x squared, or I'm dividing by 2 terms, it's 2 terms in, yes? Okay, what do you do with that 4x squared now? You're going to multiply it. So you're going to take 4x squared and multiply. 4x squared times 2x. Eight x to the third. 4x squared times 3. $12x squared. You guys realize these side steps I'm doing, take them or leave them, right? Some of you are going to want them to remember what you did 2 hours from now when you look at homework. Some of you are going to be fine without. Okay. Are you doing the next step? What do you do? Subtract. 8x cubed minus 8x cubed. It's good. 0x squared minus 12x squared. Negative 12x squared. And drop down your 0x. Repeat the process. Nope, 1 term at a time. I'm only dividing by 2 terms, so we really can only work with 2 terms. Not that you couldn't divide with the 27, but then it ended up just dropping again later also.
So if it was 3 terms, would you drop, like would you break down and work with 3 different numbers?
You would work with 3 terms. Yeah. We'll talk about that here in a little bit. Okay, so you guys working on this next one? Now it's 2x, and you're asking yourself, how does it go into negative 12x squared? So 2x times what is negative 12x squared? If your brain doesn't like that, negative 12x squared divided by 2x. What are you guys using? Negative 6x. Negative 6x. Next open spot. Also happens to be above its like term, yes? Do you see why I have the 0 placeholders now? It's keeping everything lined up and organized. Okay, multiply. Negative 6x. Negative 6x times 2x. Negative 12x squared. Negative 6x times 3. Minus 18x. So we end up with negative 12x squared minus 18x. And now you are going to subtract. Negative 12x squared minus negative 12x squared. Cancels. 0x minus negative 18x. 18x. And now bring down the 27. And last go around. This time, 2x into 18x.
Christmas time again.
2x times what is 18x? What is it? 9. What do we do with that 9?
Put it above the 27.
Above the 27. And multiply, right? 9 times 2x is 18x. 9 times 3?
27.
27.
All the cancel.
This is the distributing over here if you need to see that. Okay, now, a couple of things here. We subtract, everybody cancels, yes? What's the answer to this problem?
4x squared minus 6x minus 9.
Plus 9?
Or plus 9. Sorry.
Okay, just making sure I heard the right thing there. 4x squared minus 6x plus 9.
Yeah.
Okay, now, a couple of things. We talked about 0 placeholders there, yes? You could do this problem without them, but here's the deal. You would end up with pieces not lined up. You'd end up having the 12x squared and the 27 next to each other or on top of each other. It doesn't work out well. That's why we need the placeholder zeros. It's an organizational thing for only. Now, I mentioned 0 remainder on the previous page, yes? Anytime there's a remainder of 0, that means that whatever you divided by, in this case 2x plus 3, is a factor of 8x cubed plus 27. Okay, it also, if you have to write it in factored form, 2x plus 3 is a factor. And what is the other piece that would divide into it? The 4x squared minus 6x plus 9. You have one like this in homework, or at least one. So I'm going to write down a little side note down here. Because the remainder is 0. Okay, because the remainder is 0, 2x plus 3 is a, what word did I just use? Factor of 8x cubed plus 27. So if you're asked, is this a factor? Is the remainder 0? That's what they're really saying. The other thing I want to mention here, because I believe in homework it'll be then, if it is a factor, write it in factored form. Okay, well, factored form here means that 8x cubed plus 27 breaks into the two factors it divides by. It breaks into the factor of 2x plus 3, which is what I divided by, and then the result. What did we get? 4x squared minus 6x plus 9. So this right here, if you're asked for factored form, it's what you divided by and what you got as your answer. Those are your two factors. Okay? So get what you need from there. And then I want to try and get through this last example real quick. It has a couple of little pieces in it. Okay, so because the remainder is 0, 2x plus 3 is a factor. And then since it's a factor, the factored form is the 2x plus 3 times the 4x squared minus 6x plus 9. Okay. Let's set up this last one. be careful as you set up this last one. It gives you a hint, yes. Find the quotient. Don't forget to write the polynomials in descending order and fill in any missing terms. Okay, guys. As we set this up here, what goes in the box? 16x to the fourth minus 85. What should come after x to the fourth term? X to the third. I don't have one, so I'm going to say 0x to the third. What comes after x to the third term? 0x to the second. What comes after x to the second? 0x to the first. What comes after x to the first? A constant, a number, which in this case is minus 85. Okay, beware. In my divisor, what am I dividing by? 4x squared plus 9. What should come after an x squared term? An x. Do I have an x? No, so guess what I have to fill in? A 0x. So we're dividing by 4x squared plus 0x plus 9. Every place has to be in order, no missing pieces. Okay? Now, someone asked earlier about dividing by 3. Guess what? Here we are. We're dividing by 3. Same process though. Start with just the first piece there. Just take 4x squared into 16x to the fourth. 4x squared times what is 16x to the fourth?
Squared.
4x squared. Are you guys with it? Okay. Where do you think I'm going to put that 4x squared? Notice I put it above its like term, or how many terms am I dividing by? 3. How many terms are we counting over? 3. Yes? Okay. What do we do with the 4x squared next? You multiply. You're multiplying it by the 4x squared plus 0x plus 9. 4x squared times 4x squared, 16x to the fourth. 4x squared times 0x, I'm going to write it as 0x cubed. 4x squared times 9, 36x squared. And we are subtracting. 16x to the fourths, cancel. 0x cubes, cancel. Those don't necessarily have to cancel, but it canceled. 0x squared minus 36x squared. Negative 36x squared. Now, what do we do? Officially, you bring down the 0x. But here's the deal. I'm supposed to be dividing into 3 terms. This is only 2 terms. So what do you end up having to do? Bring down the next one also. Now, in that process, we're going to need an answer here. And this answer is just going to end up being a 0 because we're going to skip over it and bring down the next term. Okay? And you'll see what happens here real quick because I'm running out of time. What are we doing? 4x squared times what is negative 36x squared? And that is what? Minus 9, yes?
Yeah.
Put the minus 9 over its like term, it ends up over the 85. Multiply. We have negative 36x squared plus 0x, negative 81. And you'll actually have a remainder here. Negative 85 minus negative 81 is negative 4. Okay, I'm going to write this answer out. Part 1 homework is out there and available. Feel free to get it done. Okay? So 4x squared, thank you, too, minus 9 minus 4 over the divisor, 4x squared plus 9.